Wrong room, I think. I don't know. Is it not building up the front? Cav 8. No, it's not Cav 8. It's a different. No, I mean, I don't think it says CAV 8. I think it says COO 8. I'm pretty sure of it. Yeah, but it's not a block. C classrooms are up the front of the school, in front of the library. Yeah, that's it. Okay, we'll continue now, please. Did you get them all finished? Until in number 2? Yeah, but that's it all finished. Yeah, very good. Okay. Have you studied this before? Yes. You didn't like it? Yes, it gets harder. But we won't tell them that. Right, turn-in points. Okay. So, can we look up, please? Earlier in the semester, we learned how we could find this point on a quadratic called the vertex, or also called the turning point. What was the method we used to find this point? Someone must remember how to find this point. Completing the square. But the problem with this method is it only works for quadratics. And we want another method that can work for any problem. Like, for example, if you had something like this, completing the square won't work because it's not quadratic, it's cubic. But notice what's in common. If I draw a tangent here, the slope is negative, here, negative, here, positive, here, but here, 0. Here, positive, here, 0 here, negative here, 0. So do you notice what's in common with turning points is that the derivative at the turning point is always equal to 0. And that's the key for this lesson. That's how we can find turning points. So for example, let's say you had y equals x squared plus 3x plus 1, and I want the turning point without completing the square, then I can just find where the slope is 0. So when will the derivative be 0? When x equals minus 3 over 2. And then you can put that in and you'll get the y as well. Much quicker and easier than completing the square. Okay, write this down and then we'll have a look at more difficult examples.
So do we forget about completing the square?
No, it still has importance in our lives, but it's now less important. Got that?
So when the question is like, can we just explain the turning point has the divergence of 0?
A derivative of 0. You don't even have to explain that. if they said find the turning point, then they expect the first thing for you to write is derivative equals 0. Let me just get the y value here. What did I say the x was? Minus 3 over 2. Minus 5 over 4. Like that. Yep. Okay, can I scroll down? Or, well... Are we just waiting for you?
No.
Oh, so we're just waiting for Fong? Hey. That's sounding a bit Vietnamese to me. Right.
No, but you're...
No, I'm mistaken, am I?
Yeah.
Alright.
You're deceiving.
It's just a Vietnamese accent, huh? Right, y equals, let's do a cubic one, for example. So, let's see. We won't worry about having nice answers. X cubed minus 3x squared minus 3x plus 3. And I want the turning points here. Now, we could have turning points. We could have 2 points as the answer. One here and one here. So let's see what happens anyways. So dy dx equals 3x squared minus 6x minus 3 equals 0. 3x squared. That's right, isn't it?
You should have made it as a plus 3x.
Here?
Yeah.
It'll make it easier. Well, I can change that. X squared minus 2x. You're saying this is easier if it's a plus?
Yes.
Yes, agreed. I'll change these to pluses, yeah. Equals 0.
Should put that in the exam.
Oh, if only you had the power. Right, so this has actually only one turning point. Yeah. Let's put in 1. 1 minus 3 is minus 2. Minus 2 plus 3 is 1. Is it 4? Yeah. So this one has one turning point. So I want to do one that has 2 turning points. Okay, write this one down and we'll do one that has 2 turning points. Okay, can we go on to the next one? Let me get a nice one here for you. Yeah. Okay, we have y equals x cubed minus 6x squared plus 11x minus 6. So y dy dx equals 3x squared minus 12x plus 11. This isn't going to be nice. Oh well, I guess I lied. Right, so we want to solve this. I think we have to use the quadratic formula, but we'll cheat and use the calculator. Mode 53, 3 minus 12, 11. So you get 2 answers. X equals 6 plus root 3 over 3, or x equals 6 minus root 3 over 3. So what's happening here is you have 2 turning points. One of them was here and the other one is going to be here, for example, something like this. The reason you have two turning points is because when you differentiate a cubic, you get a quadratic. Okay. Can we look at a harder one then?
Even
Yeah.
if we're in the exam, could we like use calculator for quadratic and
You have to at least pretend you're using the formula. So you would have to at least write down a equals 3, b equals minus 12, c equals 11. And then if I also saw you writing down the formula, then I could believe with you that you've used the formula, but you have to give me something. I can't just, you're not supposed to just use the calculator for this. I have to see some evidence that you at least knew the formula, Okay. Continue. Yep. So I want to do one that has a log in it, which I have here. This one here. So can you write down this one here? Number 5. Now I tried to use as many words as I can because there's many different synonyms for turning point. We have turning point, maximum minimum point, stationary point, extreme point, critical point sometimes. What else? Vertex. Did I forget any? I think that's most of them. Yeah. So if you were in the exam and it said find the blank point and you didn't know what the blank point was probably turning point. There's lots of synonyms here. Okay, did you write down number 5? No, it's quite hard. I want to do it. No, actually, do try it. It won't kill you to try it. What's the worst that could happen? It's not like your head will explode. Okay, try for a minute to do number 5. It's harder than the examples I gave you. Here, I'll zoom in a bit more. You have an answer? Yep. Okay? Yep. Okay. Let's have a look at number 5. Y equals log x 18 minus x squared plus 16x plus 7. What should I do first?
18.
Correct. That's it. Now let's differentiate. So this will be 18 over x minus 2x plus 16 equals 0. What to do next? Multiply by x. And I think I'll also divide by 2. So I get x squared minus 8x minus 9 equals 0. I take everything to the right. Yeah. So what have I got here now? It has to be a plus and a minus. X minus 9, x plus 1. X equals minus 1 or 9. Accept or reject either of these answers. What do you think? No. Wow, that changed quickly. I know why you said reject minus 1, because it's a minus. But if you look at the original question, what values of x can I use? I can use any except 0. So x can be any number except 0. Is this okay? And is this okay? Now, we still have to get the y's. You worked it out already? I thought it'd be a decimal. Oh, with the minus 1, yeah. So this is minus 10, is it? And the other one?
109.985.
So 110 we'll say. About, yeah? Yeah. Okay. Now, I want to draw this so you can see what's happening. We have 2 turning points.
Is it or and?
Or here.
So
It's this.
and there are like 2 turning points.
Yeah, this is a turning point and this is a turning point. We're saying or here because it's a math thing. If you say and, it's not. You can't say x is 1 and x is 2.
Yeah, but then.
But I know in English you could say and, because you could say this is a turning point and this is a turning point. Yeah. If you want to prevent any of that, just delete. Right. So you might be thinking this is a bit like a cubic because we have 2 turning points. So one of them we think might be on the top and one of them we think might be on the bottom. But it's not going to be quite like that for this one. I want to draw the graph for you in the program here. Can you just read out what it was? Y equals log x power 18. Yeah. Let's make a graph. Right, where were the turning points? What x values? What were they? Minus 1 and 10, is it? Okay, well let's zoom out and find them. Was there one at minus 1?
Yeah.
There it is there. So, at what point was this? Minus 1 and minus 10. That's the first turning point there. Let me just mark it there. And then the second one looks like it's somewhere around about here. 9, very good. And 110. Excellent. 9 and 110. So can you see the 2 turning points there? Yeah. You notice though, yeah, I was just about to say that, you notice it looks like there should be a 3rd turning point. It looks like we have a maximum a maximum and a minimum. So let's examine. We think there might be a turning point here. So let's zoom in to see what happens. Where does it looks like it's at minus 60. Okay, let's zoom in. Oh, it looks like it's at minus 75. Okay, let's try and catch it. So can you see what's happening here?
It's going.
It's not really a turning point. What you can't actually see, it's not touching, yeah. So I know in the original graph it looked like it was reaching a point, but what's really happening is that it's actually shooting down to minus infinity. But anyways, even if it was reaching a point, which it's not, why can't we use this point as an answer? Because it's forbidden by this. X can't be 0. Yeah. So I like this example because it's more difficult than a quadratic and a cubic. In the exam they usually just go with cubics, but not always. But 90% of the time it's a cubic equation you have to deal with. Okay? Is that the door? No. Alright, let's have a look at homework here. No, because I was going to give that as a homework. So I certainly can show it next time, but I want to make you sweat over it for a little bit. Where's the last cubic one? Okay, I want you 18. 18, can you write this down? $25, 6, 7, and 8. No, sorry. I'll write them down. Question 18, 23, 24, 27, and 28. 18, 23, 24, 27, 28. You can start with the quadratics first, if you want. This one here, where's it gone? 20. Yeah, if you want, this one is the easiest one, so you can start with that one first. And the last one you should do it at the end. This is a hard one here. 18 is cubic? Yeah, I did one like 18. 24 I did one like that. And 27 is also a bit hard. Just a little bit. Okay, can you start those now? You don't, but do it just in case. I've learned so far in my life that even if you rang them up and said, "Do I need to print it out?" and someone on the phone said no, still print it out, because the last thing you want is to be in front of someone saying, "And where's the email?" and you're like, "But the person I was talking to said I didn't need it." It's like, no, you need it. See you tomorrow. No, my point is, even if you don't need it, even if someone said you do not need it, bring it.
No, like
He's giving us words of wisdom.
Exactly. Yeah.
This life advice.
That's it, yes.
Mahatma Gandhi.
like if you have it on
For
your
visa
phone,
office, yeah.
Exactly.
even if you have it on your phone, you know,
Yeah, because as far as see what I'm saying.
you need to print it. How am I gonna print it?
There's a cafe over there. I'm going to it after this.
or use the school.
No, it can go to the library.
The library.
Yeah, no, you can go to